Good afternoon, ladies and gentlemen. I know it's late in the afternoon, but I would still very much like to welcome you to the Leo Foundation Awards ceremony. So my name is Ida Brams, and I am the Chief Grant Officer of the Leo Foundation. The Leo Foundation is a Danish foundation, and since 2011, we have provided philanthropic grants for over $80 million to support research in skin and skin diseases all over the world. Through our philanthropic activities, we aim to support the best research in dermatology. We give out grants, and we have our Leo Foundation Awards. Our awards are global awards of $100,000 that are presented every year to young researchers. One from each of the three regions, the Americas, Europe, Middle East and Africa, and Asia Pacific. Today, I am really proud to present the Leo Foundation Award for Region Americas to an outstanding young scientist whose work represents an extraordinary contribution to dermatology research. And it is an honor and a great privilege for me to be able to share this moment with you at the SID meeting in Chicago. The winner of this year's award has been selected among all the regional applicants, and all applications have been reviewed by a global panel with reviewers from the American SID, the ESDR, the Japanese SID, Korean SID, and Taiwanese SID. And I'm really grateful to our reviewers for their help in making these awards truly global. The Leo Foundation Board of Trustees has decided on the winner, and now we're almost there. The winner of the Leo Foundation Award 2019 for Region Americas is Dr. Maksim Pilkus. So Max, I am truly happy to present you with the Leo Foundation Award. So Max, you've already been on stage and we've all heard about how you got your PhD in pathology and that you've since pursued research at the University of Pennsylvania and the University of California, Irvine. And before you tell us just a little bit about your research and actually why you became a researcher, I would really like to share some of the reviewers' comments with you and the audience. So here is what they said. Max has innovative research ideas, and the scientific results obtained from his work have significant translational value. Max's research is highly original and shows incredible vision, and his work is already having a major impact on dermatology. Max's research challenges paradigms, and he shows potential to become a leader in the field. And Max's work is highly innovative, exploring new frontiers with high-risk, high-reward ideas, and his future career will be incredible. On behalf of the entire Leo Foundation, I want to congratulate you on receiving this award. So, the world needs a lot more research in skin and skin diseases. And I wish you, Max, and all skin researchers the very best for the future. So thank you all for coming, and especially those of you that stayed. And now, Max, please.
Ida, thank you so much, and thank you for all of you who decided to stay. I know the last thing you want is to see me here, since I already hogged a lot of time. I'm extremely flattered by this award and the comments that I received. So Ida asked me to spend a few minutes to address a few things about my background. She asked me to tell you why did I get in research in the first place, why hair, and what continues to drive me. So today I will share with you my first hypothesis-driven experiment. The year was 1993. I was 13 years old, spending summer with my sister at my grandparents' rural house. One of our chores was organic farming. We were tasked with picking Colorado beetle larvae from potato plants that would otherwise die from infestation. And the way it works, you put them in the bottle and then you drown them by putting water. So after picking hundreds of larvae, I forgot to add water and it tipped over overturned. Next day, to the horror of my younger sister and to my huge excitement, I noticed that all larvae crawled out of the bottle and were crawling around her green plush bunny toy. So this initiated a hypothesis that larvae primarily are driven by the eyesight to identify the food. So over the course of next 2 summers, I designed a series of experiments, and today I want to show you some of it. None of it is peer-reviewed, so take it for what it is. In the first set of experiments, I placed 3 larvae in approximately a center of the square container, and in one corner I placed either potato leaf or typically not edible for the bug, clover or stinging nettle leaf, or for that matter, green cloth. As you can see, in all cases, larvae beelined to the green color, meaning that they indeed rely primarily on vision to identify food. In the next set of experiments, a larger round container was used and 100 larvae were placed in the center, and at the periphery of the container were placed potato leaves wrapped in white gauze or green cloth. As you can see from this graph, over the course of next 5 hours, primarily larvae localized on the green cloth and were not able to identify otherwise edible potato leaves covered in the cloth. In the iteration of this experiment, I replaced cloth with 2 unedible type of plants, shown here in blue and red lines, and potato leaves were again covered until the hour 5 of the experiment, at which point I uncovered it from the gauze, and as you can see, over the course of next hour, almost 100% of larvae went straight for the potato and were eating it. So this also shows that in addition to vision, they do have strong preference for what's edible, and they're able to discriminate between potato and non-potato leaves. And finally, I performed another set of similar experiments where I tested again the food preferences for different leaves. So on the left is the comparison of potato with bean and lily leaves. You can clearly see that they prefer potato. But what's really exciting is that when you replace beans and lily with tomato and pepper, which are actually within the same family as potato, then the picture is much less clear. There's actually a large number of larvae that prefer tomato leaf and to a lesser extent pepper. So the taste qualities of those related plants are probably similar. So this is something that I performed in 1993 through 1995. Sometime later, I kind of stopped doing bug work and instead I caught hair bug from these 2 people. These are my former mentors, Ming Chong and George Katsarelis. Warning, I'm still contagious. You can ask my students. So one thing that both of my mentors did right is that they really showed me very early on some really fascinating and unexplained phenomena, that of patterned hair growth and wound-induced regeneration, and it really captivated my attention and really drove me to study it. What continues to drive me forward is really in nature. So outside of the typical laboratory animal models, hair biology is actually highly fascinating. So here I will conclude by showing you 2 examples of 2 interesting animals. So one is called African crested rat, which has this side patch of orange hair that is hollow in the center and acts as a sponge. African crested rats actually chew on highly poisonous cardiotoxin containing local bush bark, and they have immunity against the toxin, but if predators such as local dogs attempt to bite them, they would actually die from it. So it's one of those examples of acquired toxicity in mammals that is clearly related to hair biology. And in case of sloth, what sloth have, they have very specialized hair, the very specialized hair that is green, and yeah, very specialized hair that is green. And green actually comes not from the natural pigment, but from photosynthetic algae that reside within the hairs and provide extra nutrition for sloth, which lick off algae from the fur to supplement the nutrient-poor leaf diet. And finally, I think inspiration also comes from classic literature. Time and time again, I become convinced that in literature that spans last century, there's this really beautiful observations that people have documented whose thinking was not really clouded by the current technologies, and they were able to really beautifully and convincingly document something that we are continuing to work now, such as wave growth patterns identified in 1945, a wound-induced hair neurogenesis in 1950s. With that, I would like to conclude, and thank you again for your attention, and thank you, Leo Pharma, for this award. I'm truly honored.